So this lesson is just a quick review of some factoring techniques that are going to be important to us when we start working with derivatives that we find using the chain rule. So all we want to be able to do at the end of this is to be able to common factor expressions that have negative and fractional exponents in them. So let's just jump right in here and take a look at an example of common factoring. So we've got an expression here, x to the power 4 plus 10x cubed plus 3x squared. And we want to factor this. What can we factor out of each of these three terms here? Okay. Yeah, we can factor out x squared. Now, how do you know we can factor out x squared here? Well, each of these terms has a power of x, x to the fourth, x cubed, x squared. X squared is the lowest power of x that we see. So that's the one that we can factor out. And what do we mean by factor it out? Well, your teacher may have shown you this way back in grade 10 when you first did factoring, or maybe even did factoring back in grade 9. But if we're factoring out x squared, we're going to bring the x squared out in front here. We're going to have a bracket. And what goes inside this bracket here? Well, we take each of these terms, x to the power 4, 10x cubed, 3x squared, and we divide each of them by this thing that we are factoring out. And then we do this division, and that is going to give us our factored expression. So x to the power of 4 divided by x squared. Let's see, we just subtract the exponents. We're going to get x squared. 10x cubed divided by x squared. Again, we are going to subtract our exponents, and we're just going to get x. And in the last one, our x squareds cancel out, and we're left with just a plus 3. So we want, you're so good at this now that you don't even think about doing this division step while you're doing it. But as we go on to other more complicated kinds of factoring, it's going to be helpful just to think about that division step as we're doing it. So our next one here, slide this up, 3x to the negative 2 plus 10x to the negative 3 plus x to the negative 4. Okay, we've got an x common to each one of these terms. So what can we factor out here? Sorry? X to the negative 2. Now, why do you say x to the negative 2? True, we can factor out x to the negative 2 from all of them. But, Riley, why do you say x to the negative 4? Yeah, that's our lowest power of x. So that's the one that we want to factor out here. So let's think about what we're doing again here. We're taking x to the negative 4. We're bringing it out front. And inside, we're going to have 3x to the negative 2 divided by x to the negative 4 plus 10x to the negative 3 divided by x to the negative 4, and then x to the negative 4 divided by x to the negative 4. Now, if we do our division, we have x to the negative 2 minus, well, we're subtracting the exponent. So when we're doing our division. So we're going to keep the x the same, subtract the exponent. It's going to be negative 2 minus negative 4. But if we're subtracting a negative, we end up adding those two. So it's going to be negative 2 plus 4, which gives us 3x squared. Same thing with our next term. We're going to have a 10, and we're going to do negative 3 minus negative 4, which is just going to give us x to the positive 1. And once again, our last term seems to cancel here. So again, we always want to factor out the lowest power of x that we see. What if we have fractional exponents? 2y to the 2/3 plus 6y to the 5/3 plus 8y to the 8/3. What do we want to factor out in this case? Malcolm. We can factor out the 2 and y to the 2/3. That's the lowest power of x that we see. So this time around, well, I'll just skip that dividing step. Okay. So if we factor out 2y to the 2/3, we're going to have a 1 here plus, let's see, 6 divided by 2 gives us a 3. And again, we're subtracting these exponents. So 5/3 minus 2/3 gives us 3/3, which is just x to the 1. And finally, 8, we factor out the 2, we've got a 4. 8/3 minus 2/3 gives us 6/3. 6/3 is going to be 2, so y squared. And it could be possible that we can factor this trinomial that we have in the brackets here, but I don't think we can in this case. All right, our last example here, factoring. Two times y plus 3 to the negative 4, y minus 4 to the power of 4 plus 3, y plus 3 to the negative 3, y minus 4 all to the 3. Now, before we think about what we're going to factor out here, let's just think about how many terms we have. And all the ones up until now, we had 3 terms. Here, we only have 2 of them. Okay? We've got that 1 plus side in the middle, and in front of it, we've got one term with this times this times this, and behind it, we've got this term times this times this. So we want to factor out something that is common to our terms. So what is common to each of our terms in this case? It's not a variable, instead it is a binomial expression here. So we've got y plus 3 here and y plus 3 here. We've got y minus 4 in the first term, y minus 4 in the second term. So we're going to want to factor out, let's say, the binomial terms. What power of each of these binomial terms do we factor out? Like, for instance, we've got y plus 3 to the negative 4 and y plus 3 to the negative 3. Do we factor out y plus 3 to the negative 4 or y plus 3 to the negative 3? Same rule applies. It's the lowest power of the binomial that we are going to factor out. So factor out the binomial terms. Again, look for the lowest power. So our lowest power of y plus 3 is y plus 3 to the negative 4. Our lowest power of y minus 4 is y minus 4 to the 3. So those are the 2 terms that we are factoring out. And what are we going to be left with? I should have left myself more space, but we'll just go down to the line below. One way of organizing this is to say, I started with these 2 terms. That means that I'm going to have 2 terms in these big square brackets when I'm done. Just like these previous examples. I started with 3 terms up here. Inside these big square brackets, I've got 3 terms. So if I've got 2 terms, let's just divide those 2 terms that I'm going to be left with. Okay? Everything that starts in front of that plus sign up here has got to end up down here in front of the plus sign. Everything that's in the second term on the other side of the plus sign has to end up in the second term inside our square brackets. So this 2, right at the beginning, has got to stay in that first term. I've factored out y plus 3 to the negative 4, so I've already taken care of that term. I'm going to have y minus 4, and if we subtract our exponents here, 4 minus 3 just gives us 1. Our second term, or everything after that blue dotted line, let's see, I've got a 3 there. I haven't factored that out, so there's still going to be a 3 there. I've factored out y plus 3 to the negative 4. So I've got y plus 3 to the negative 3 right here. If I subtract those exponents, I get y plus 3. Y minus 4 to the 3, I've already factored that out in front, so I have nothing left inside the brackets. So this is that expression in factored form. And now at this point, we've got, we could simplify this expression we have in the square brackets. The stuff out front is going to stay exactly the same. In the square brackets, we can expand and collect our like terms. So 2y minus 8 plus 3y plus 9. And then collect our like terms. Let's see, 2y plus 3y gives us 5y, and negative 8 plus 9 gives us a positive 1. And so there we are. That expression is now in as factored form as we can get it. And we know it's factored form because it's something times something else times something else.